Hey guys, so I'm Josh Higginbotham. I'm based out of Louisville, Kentucky. I work for a company called Republic Bank. We're a local regional bank. I'm a data services manager, which basically means I work in ETL, BI. It's just a fancy title they gave me. I'm a 2019-2020 PASS nomination committee member. So what the NomCom is for PASS, they're the people that go out and vet the board of directors that are being voted in. So while I'm down here, I would love to hear what you want to see out of the PASS community, what you would like to see out of your board of directors. That way I can give that info back out to the NomCom and we can maybe address some of that stuff when we start vetting out these board of director seats. I'm the co-chapter leader of the Louisville SQL Server and Power BI user group. We meet monthly. Our schedule is pretty flexible, so if you know anybody that wants to speak, whether they're a new speaker or a veteran speaker, we'd love to have them up there. If you want to get a hold of me over anything that we talk about today, the best place to find me is on Twitter. I watch it pretty heavily. My Twitter handle is @codenamesql. You can find me on GitHub at jhiggin, or by email, which is my name @codenamesql.com. So what we're going to cover today is a brief overview of GitHub as an organization, how it was formed, some history behind it. We're going to then set up the remote environment. So this is the website that you see when you go watch anything from Brent Ozar's channels, the DBA Tools group, stuff like that. That's what you're seeing is this remote environment. Then we're going to cover working with Git and GitHub locally on your system. That way you can make code changes, work peer-to-peer, and then push changes up. Is there anybody working with GitHub right now, day to day, whether it's in a work capacity or a community-based capacity? Okay. Is your knowledge of it pretty bare bones? You know enough to get by, and that's about it? That seems to be about the majority. So it is an introduction. So we will cover a lot of this, but we'll try not to go too advanced with it. The biggest thing that I want to ensure is that you get a good understanding of how to secure your repositories in that remote environment. That way people can't adjust your code without you knowing. So quick overview. This is just a general timeline for GitHub and Git as a system. So Git was created by the Linux community in 2005. This was when a company they were partnering with called GitKeeper, the relationship failed. And so they were faced with the need to source control their systems. So they designed Git, their version of Git. And in reading it only took them about 2 weeks to do so. So they turned it around pretty quickly. In February of 2008, GitHub was founded. So this was the first commit done against GitHub. So it's a fairly young company when you start thinking about others within like the Silicon Valley area. Within about a year and a couple months, they were at 100,000 users already. And then we'll just go straight to the end of this. In August of 2019, they reached 40 million users. So it's not just this open source repository system. It's being leveraged by open source communities. It's being leveraged by enterprise level systems and companies, both within the US and within the global area. So 62% of the US Fortune 50 use GitHub Enterprise. So what GitHub Enterprise is just an additional plan on top of the package that you can order within GitHub. So you can have a cloud hosted enterprise edition, or you can have an on-premises that you install. That's the only difference. And it comes with some additional security layers and stuff like that. So when we start talking about source control types, we need to understand what types of source controls there are. Who works with TFS or TFVS currently? Because that's what most developers are born out of, especially around my generation. You know, if you go back to the Micro Focus COBOL days, you may deal with some other types. But you started out with centralized version control systems. So the way I try to generalize the image of a CVC system is the mothership from Independence Day. So it's a single source of truth for your source control system, and you always have to keep communication to the mothership to be able to reference certain things like history. You have to keep those relationships bound. So if you've ever had to unbind and rebind your repos, that's that link that you have to keep established. So if in the case you're on premises with your system like TFS, your server goes down, your development process comes to a halt. So you have that single source of failure because of this. So what Git does is it comes up with a distributed version control system, which means that everybody gets a copy of it. And I imagine this like Oprah. So everybody gets a copy. So when you do a Git clone, or you're forking the code, you're taking a whole image, a whole copy of that source control system and moving it over to your system. So that's every history that's ever, that's a history of every change that's been made against that repo since the beginning. That opens up you to some security risks though. So in the case of API keys, security tokens, passwords, if those are stored in plain text within your repository, even if you change those passwords or you remove those from your repo system, they're still stored in history. So somebody could go back and look at those. So when you're designing out your source control systems within GitHub, you want to make sure that you account for certain things like that. You know, don't store certain things in plain text. Try to use variables within your automation systems to pass in those variables, and they're stored within a key keeper of some sort. Distributed version control systems are snapshot-based commits. So when you issue a commit, what it's doing is it's taking a snapshot of that repo as it currently sits and then just creating a pointer back to it. Whereas a centralized version control system, it's a delta-based system. And so when you're doing rollbacks or looking at history, it's doing those differentials based off of those types of commits. Anybody have any questions so far? This is we're going to blow through a lot of this. That way we can start working with the actual command line interface and we can go through some of these tools. So setting up your remote environment. So this is going to change based off of the type of project you're going to be working with. Is it an open source project? Is it just a place for you to store your scripts and that's it? Or is it a enterprise level product that you want to make sure is secure, that people aren't checking stuff in without your approval, stuff like that? So the first week or two, you may end up spending it on paper, just lining out the requirements behind your repo, your system. So to help, what you can do is look at the feature comparisons within GitHub. I've put in hyperlinks to all of these, and see if I can pop this up real quick. Let's see if I can minimize. So within this, oh, that didn't go over. Yeah, this isn't working. All right. What is going on? Sorry, let me reset my PowerPoint. We won't try that. So we won't go into the links. The slide decks will be provided at the end of this. If you go to the links, you'll see some more on this. GitHub basically has 4 features currently. The free plan is always free. There's no cost. You don't have to put in a credit card or anything to be able to use the free base plans. Recently, they opened up private repos to free base plans, so you can have as many private repos as possible, or as you want. They just cannot go over 3 collaborators before they start making you pay for something. So after the free plan, it goes to Pro, which is, I think, currently $9 a month. And basically, it just allows you to have unlimited private repos with unlimited collaborators. That's it.
You've used the term repo a few times.
Okay.
What does that contain?
So,
Repeat the question.
so the question was, we've referenced repos a lot within this. A repo is a repository of something. So it could be source code, it could be text files, whatever you want. Source control, all it really is a storage system that has change tracking enabled on it. So once you get past Pro Plan, then you have Team, and then you go to the enterprise level pricing. All those have pricing models on the page until you get to enterprise. If you need to get enterprise, you're going to have to reach out to a salesperson to get that. We then set up an organization. So to set up an organization, it's a pretty simple 3-step process. You do have to give them a billing email address, but as long as you say it's for open source, there's no credit card info has to be provided at that point. And what an organization is a way of saying this org owns these X amount of repositories. So when you think of it in a open source fashion, you may have an organization that has 3 or 4 teams that are working from it. So in the term of the DBA tools repository, it is under the SQL collaborative organization. And you would use an organization for security. So you set up your organization, then when you build out your repositories, you set them to private repositories. And then you create teams. That way you can say this team has access to this repo, this team has access to this repo. If you set them to public, then anybody and everybody can get to those repos. You have a question?
Yeah, now the repositories you set up on GitHub, those are ones that are like central repositories in a way where you keep all of your primary source code stuff that's not being worked on, or that's something that has been approved for production, or...
So the question was, on the remote side, if I understand it correctly, that is where your source code lives that is kind of production worthy?
Correct.
So yes, you may have additional branches that will live out there on the remote system. They could be staged there waiting for you to review them and merging them into your trunk or your source of truth.
The GitHub side is actually where you store your production approved and anything that's waiting to be production approved as a branch or whatever.
Correct. And then there may be, as you're working on code, you may branch that off to kind of work with it internally.
But stuff you actually are working on sits on your PC.
Correct. And you don't have to keep a connection to the remote, so you can pull everything down, disconnect from the internet, and work with no issue because of the way this distributed model works. So once you create your organization, you got to start thinking about project licensing. So you can license a repository in many ways. There's 2 links embedded in this slide deck that will help. The first one, choosealicense.com. If you go there, you can answer 3 or 4 different questions about what type of project this is, and it'll recommend a best use license for this. And all a license does is it allows you to dictate what the code is supposed to be used for. Can somebody go out and modify it and reuse it, or if they modify it, they have to send that modification back to your system so you can keep it up to date. Any open source licensing is going to be one of those warranty as is type scenarios. If you go execute this against your production system, it's on you if it goes haywire. So it's to protect you as much as to protect them. We then start talking about like the initial setup of projects in general. I label this as open source projects, but you can adapt some of these for your enterprise systems or even your public. So you start off with a README file, which is just Markdown, and all the README file is kind of like the index file of a website. It's the landing spot you go to when you hit it in the repo, and basically it gives you instructions on what is this project for, who do you contact if there's any issues with the system, or do you want to request a new feature or a bug. It gives you instructions on how to do that. You then have a contributing Markdown file, and what that says is if you want to contribute to this project, these are the steps that you need to follow for us to accept your code into our system. And as long as you follow these steps, then we'll approve the pull request to allow it to come into our system. And then we have to have a code of conduct. So unfortunately, in this day and age, people still need to be told how to act. And so the code of conduct basically says if you do not adhere to these terms, we have the right to block you and remove you from our systems. No questions asked. And GitHub makes it easy. So when you add a new file into a repo and use the code of conduct nomenclature, it will automatically pop open a button that says, help me create one. And it'll give you 2 recommendations for code of conduct, and we'll show that in a little bit. For additional info on building out an open source project, you can go to opensource.guide, and it's a full top-down documentation of how to build out an open source project efficiently, and to ensure that you're covering all of your bases. So securing your project. So this comes from different forms. You want to make sure that your branches are secure. That way people aren't doing pull requests and merging the code automatically. It's securing the branches and the teams and the branches and the repos through teams. And we'll go through that. Some of that is just getting a better understanding of what the project is about. So if you've got a very low risk project, you may only want one approval for the merge to go in. But if you have like your general ledger system that if somebody modifies this and it's going to just take everything into the weeds, you may want to have 2 approvals before it goes into production. And I think you can go up to 6 approvals is the max currently for that. And this is an example of what happens when you don't properly secure your project. So I have my blog website. I'm a terrible blogger, but I built it out because I wanted to kind of be nerdy and build out a website that was continuous integration. And to do so, I had to switch it from a private repo to a public repo. Well, I had my API keys, or my AWS keys, in plain text in a file. And so when I moved it from private to public, I was immediately notified by AWS that my keys were exposed on the internet. And they shut my website down and gave me the info that I needed to adjust. So there are protections in place that when you do screw up like I do from time to time, that they will, parties, GitHub also notified me of this, that I had exposed keys. And so what I had to do was generate new keys, change them on AWS, and then use variables within my source control system and pass those in through the CI process to do it. Then there's vulnerability. So over time, the open source projects that may be tied into yours may have vulnerabilities, third-party DLLs. And so GitHub will track public vulnerabilities within certain languages. It's morphed over time. They've recently bought a company called Dependabot, which has changed. So originally they would track dependencies and they would just alert you that there was a vulnerability. And you would get an email weekly of your vulnerabilities by projects. With Dependabot, what it'll do is if it can correct the dependency for you, it will correct it, open up a pull request with that fix, and all you have to do is review it and accept the pull request, and it'll merge that code in. So they've added some features that will autocorrect vulnerabilities for you so you're not having to spend time to do so.
You know, for someone that's never used Git, a pull request is a foreign thing. You might want to just
Yeah, so
explain what that means.
we'll cover pull requests a little bit down the line. So this is just overviewing some of the stuff. When we get into doing the code aspect, we'll cover pull requests.
So, if you're working at a company that considers their code, you know, trade secret or whatever, and then all of a sudden GitHub is reading the code and telling them which pieces of their code are not acceptable, isn't that going to set off some red flags that, hey, you know, is this really secure?
So the question was, if GitHub has access to your repositories and you're working with a highly compliant source system, whether it's proprietary code or it's...
I mean, let's say you're doing banking.
Yeah.
You know, and you don't want some guy at GitHub to go in there and start, you know, creating their own bank accounts and stealing everybody's money.
So I don't work for GitHub, so I don't know their security layer. I will say there are certain features that you can disable. So like Dependabot, you have to authorize it to access that repo. It doesn't just get enabled by default. So a lot of the add-ins to GitHub, you have to authorize it. And this all goes back to security, so ensuring that set individuals within your company have the rights to be able to add these. Because if you're not careful, you can enable a third-party add-on at an organization level. And so it's going to affect every single repository from top to bottom. That's stuff that you're going to have to look into as you're going through this, but it's the same concern that you would have out of Azure DevOps. It's just a separate company, separate entity. So instead of GitHub having visibility into your system, it's Microsoft, which now are one and the same. So GitHub was acquired by Microsoft last year. So they're owned by the same people. .gitignore files are a way of addressing some of that. So what a .gitignore file is doing is it's creating a filter file. So when you do a copy of the code to your local system and you're going to make changes, that .gitignore file basically states when this person goes and does a commit, filter those out from the commit. So if you have a file that stores your variables for your keys, you add that to the .gitignore. So if somebody goes in and tries to modify it and put the plain text keys back in it, it's going to get filtered out of the commit, and they can't push those keys back up into your remote system. .gitignore files was one of the hard points for me to understand initially on. But it's not just for files, it can be for directories, so you can filter out a full directory if you needed to. So the next couple of slides we're not going to cover. This is mainly for you to just go back and look. All it is commands that you're going to use locally. In the resources panel of this, there's a Git cheat sheet, which basically has this, and it gives a little bit more detail on it. But we'll get into the commands a little bit once we go into the command line. The working states and areas that we're going to cover, though, are kind of important. So this is basically on the local system that you're working from as a developer. Changes can be in 3 different states. You have modified / untracked changes. So that's files that you've made a change to, but they haven't been added and staged for the next commit. Untracked changes are new files that you've added to your repo locally. GitHub doesn't automatically start tracking files. You have to tell it to be added to the change tracking system. Then you have staged. So staged is you've added it and it's ready to be committed, basically. And then committed is it's committed locally. So that doesn't mean that it's been pushed up to your remote. So you can commit multiple times a day locally and only push to your remote when needed. When you push, that takes all that, all the commits that you've made during that day, pushes it up to your remote, so now it's off your system. And at that point, you would have to be connected, obviously, to the network, to the repo. Branching. So branching, it exists in GitHub, or Git, sorry, and it exists in TFS. It's not really new, just a strategy behind branching. So in TFS, you tend to have branches that are long-lived. A dev, QA, stage, prod branch, and they're permanent branches, and they're just used to track things as they flow through. In Git, branching is a very short-lived system. So you'll always have your core branch structure. So that's your trunk. By default, the first repo that gets created, the first branch that gets created off of a repo is called master. That's just the default name. You can adjust that. There's no dependency to that. But from there, you can branch as many times as you want. Most people will create a dev branch, and then that's just your kind of your sandbox, your playground, where you test all your merges to make sure that they'll build and they'll work properly before you introduce it to your trunk system.
Is the branch basically nothing more than a folder?
Correct.
You make a branch, it doesn't automatically copy stuff from master into it, it's just a holding spot.
Correct. And it basically takes a snapshot of whatever you're branching off of, creates a pointer back to it, and then as you work, so you branch off for, say, a feature branch, and you start making changes to it. and you get a report from a business unit that there's a massive bug in production. So you need to halt what you're doing in development and fix that bug. So what you can do is you can either stash those changes, or you can commit those changes to your feature branch that's local, then go back to your trunk-based branch off that for a hot fix, and then fix the hot fix and get that resolved without having to do anything too crazy. And we'll go through an example of that shortly. So this is an example of branching. This is the Git flow that you'll see, and it's confusing. So if you try to start off your Git life with this type of branch structure, you're going to get lost quickly. So when I started working with Git, I stuck to a master branch, which I called trunk, a dev branch, which was my playground where I would test my merges and all that. And then I would create feature branches for anything that was going to take more than just a day. And that's on you to build your own coding standards for that. You could go and do release branches and so forth and so on, but try to keep it as simple as possible when you first start out, because merging can get cumbersome if you have the more developers that you get and the more developers that are working with local-based repos, the merges will get complicated over time.
Question, when you create a branch, does that start off with all the code of what it branched off of, or is it just some portion that you're doing for a feature?
So the question was, when you branch off of an existing branch, does it make a full copy of the current branch, or does it only branch items that you choose to? So when you create a branch off of, say, your dev branch, it's going to take a full copy of that and move it over. Now your changes are only going to be or your commit will only be what you actually changed on that. So remember, GitHub or Git is a snapshot-based source control system, and so and we'll kind of go over that a little bit further down the road, and you'll kind of see an example of that when you start to make changes.
And when you said branch, full copy, it's a full copy. It's not pointers back to the parent.
A pointer is created, and so let's see if I can get up and show this. So this is commits, basically. Or releases, I guess is how they're actually doing this. But as you commit, you're just moving down this workflow. And so when this drop-down happens, this is a branch. And so it's making a copy of v01.0 and moving it into your dev branch.
I mean, real copies.
Real copies, yeah.
Not pointers back to something else.
It's going to keep a pointer. That way there's a relationship between this. So when...
But the pointer is only relationship between the branch and what it branched off of. It's not an actual physical folder someplace where code is being stored. Right?
No, so when you create a branch, you will not see a new folder within your file structure. So it's kind of like an in-memory system. And so the source control system just creates a pointer based off that snapshot that there's a relationship between the master branch and your dev branch, and your dev branch to your feature branch.
Okay, so it's not really making file copies.
No.
Data copies.
Within the source control system, there is a copy of something happening. It's just not visible to you as exactly.
So commits normally when it's the green dots.
That's just they color coded the branching structure to just make it easy to follow. So the master line is in green just to show you these are commits to the master branch, whether that was a merge to the pull request. And this is why I said, like, this can get a little confusing really, really quickly if you leverage all these different branch structures.
Okay, so that purple feature 1 going up to the blue develop, that's a commit into the develop branch.
Correct. That is a merge. And so if you look at that, so we started off with 2 commits to master. After the second commit, we branched down to our dev branch. We then created a new feature 1 branch, And there were 3 commits to the feature 1 branch until that developer merged back into dev, and then created a release branch, and they released it to some environment, and then, so this can get a little confusing really quickly. And so this is on you to decide how you want to build your branch structure. There's a handful of different groups that say this is the right way, this is the right way. If you look at Git Flow, if you Google Git Flow, you'll find about every single one of them. So we'll go through the additional resources real quick, but if you want to get some more info on branching and you don't want to go through the process of building out a repo and all that, you can go to this website, and it's pretty much a video game on branching. So it's this internet-based system that you can kind of mess around with branching without having to worry about messing up your GitHub account. There's GitHub tutorials, and basically what that does is it creates an issue, and there's a bot behind that issue that will work with you on a set task, whether it's creating markdown files, is it merging code, is it branching. And then there's this GitHub cheat sheet that we talked about earlier, which has all the commands that you'll probably use. Unless you want to become the power user of Git within your organization, then you may want to go and get a book about Git. So we'll get into the exercise. We're going to start out by creating an organization. So again, this is a way for us to just group all the repositories that we're going to work with as an organization, whether it's an open source project or a company. So to create an organization, you have this account switch to the top left. When you first log in, this is the default dashboard. This is all the activity against any repository that you have access to, any organizations, or any users that you follow. So whether they're making changes or they're following others, this is just a good landing spot for you to see what's changing. So we go to the switch, and then we'll create an organization. That way I don't mess up. We are going to copy and paste. Let's see. Call this the TriPass demo org. We're going to select team for open source, so it'll give you some info around that. Again, anything that's open sourced is $0 per month. All you have to do is give them a billing email address, but they don't ask you for a credit card. And then you have to set ownership. So this is important. So when you're building out a project, whether it's open source or enterprise, ownership means about everything. If I say my personal account is the owner of this organization, and there's a fallout from our relationship, I have to be willing to give that ownership up. You going to GitHub and saying, hey, this person is no longer with our company, you're going to have a little bit of a battle to get that altered. So when you're building this out, think of registering your business with GitHub. That way they track the ownership in that fashion. So these are some of those questions that you need to ask yourself before you move forward. But in this case, we're going to go with my personal account, and we're going to create the organization.
You know if any of this changed when Microsoft acquired them? Or is it the same as it's always been?
So the question was, has there been any changes since the Microsoft acquisition? So Microsoft acquired them again. It was, I think, June of last year. So it's been over a year. There have been changes, but I've only seen good from it. So they've committed to staying open source supportive. They're showing this by opening up private repos to the free users. They're adding things like Dependabot. One of the new features that is still in preview and is coming out soon is called Actions. And what Actions does is it's a continuous integration system, but it's an automation system. So GitHub didn't have something native, so you had to reach out to like Travis CI or another like Jenkins to do your CI, which just adds an additional layer to your systems, which then, when you think security, opens up another portal into your system that could be taken advantage of. So I haven't seen any downfall from it. It should tell you where Microsoft stands with their source control system. So Git repos have been available within their source control system for a good while now, both on the on-premises version and the Azure DevOps Cloud version. With their acquisition of GitHub, again, I don't work for GitHub, don't quote me on it, but that should tell you where TFS may go if they're spending. I think the purchase on GitHub was in the $7 billion range, so they're pretty committed to it. Once we create a GitHub organization, we can go ahead and add members if we know of them. This just grants them initial access to what you got. You'll then build teams around that to do security, whether it's to these set repos. You may make Kevin a code owner of something. You know, Kevin's going to maintain these X repos. I'll manage these X repos, stuff like that. In this case, I'm lonely, so I'm going to skip this step. If you want to view who is currently accessing your organization, they'll show up in this pane over here. Or you can hit the People section, and it'll list out who are members of your organization. Do they have two-factor authentication enabled? Is their visibility public or private? So currently nobody would be able to see that I'm a member of this organization as the owner of this. I could change my visibility to public, and then you could use an @ mention, which is @jhiggin, to notify me of something. You can message me. But currently you wouldn't be able to reach me. And then I'm an owner of this organization. So I have full rights to do whatever I want with this organization. I could drop it right now if I wanted to. And is this person a member of any teams? We can then create teams to basically secure our source control system. So you could create a dev team, a BA team, a UAT team, which includes all of your stakeholders, and secure your repos in various fashions. So GitHub has a handful of security roles. They don't have custom-based roles where you can modify them, so you need to research what rights are given through those roles and adjust accordingly. So we'll create a dev team, and we'll set them to visible. And by default, when you create a team, you become a member of that team. So as the owner of that organization, keep that in mind, because you may get notified of every single thing that changes within that team. And within the team, you have a discussion pane. So GitHub is a collaborative tool. You can talk about things, you can collaborate on issues, on repos, stuff like that, all through this. So now that we have our team built, we're going to create our first repo. So if we go back to the repositories pane, we hit create a new repository, and we give it a friendly name. So we'll create a TriPass demo repo, give it a friendly description, and you have two options on your repository. Do you set it to public, or do you set it to private? In today's session, we're just going to set everything to public, but in private repos, you would want to use this in conjunction with teams. So the tax accounting team doesn't have access to the shipping team's repository, something along those lines. I always initialize my repositories with a README file. We discussed this earlier. Basically, this is just a front page of your repository to give end users what this project is for. I'm going to skip the .git ignore, but we will add a license. So the predominant license that you see out of the community is the MIT license. If you go to that chooselicense.org, you'll see the details behind it. So now that the repository is created, we can go ahead and start working with our initial setup. So the first thing that we'll do is we'll create a dev branch. So to create a branch, all you do is go to this branch switch, type in the new branch name that you want, and hit enter. And it'll pop into your branches screen. So this would be limited by your security measures that you put in place on Teams as well. That way everybody within your org couldn't create these. Now that we have our dev branch, we need to create a couple files. So we'll create our code of conduct. And again, as discussed before, GitHub by default will give you a couple code of conducts that they've built out within the community. So when I type code of conduct into that file name, a button shows up for us to click. And they have two different templates that you can use. So you have the contributor covenant, which basically states what you can and cannot do, or I'm going to block you. And then the citizen code of conduct. And all these have variables built into it. And you just fill out the info that is in this right pane, and it'll fix it into it. And when it's created within your repo, it's filled out with all the info. So it's pretty easy to build it out. So there's really no need not to use this. So we'll use the contributor covenant, and I'll put my email address in, review it, and submit it. And before you can make any changes to a system, you have to commit it. So GitHub will not allow you to just automatically make a change to a repository. You always have to review it and then commit it to either the master branch, the trunk branch, whatever you've set as your default branch, or you can create an additional branch. So to show you what a pull request is, we'll just commit this to a new branch, and it'll automatically open up a pull request. And so what a pull request is me stating that I have a change I want to introduce into your system. And I'm going to compare it against our dev branch, because that's my first step. I want everything to go into dev and then flow into master. We give it, the pull request, a name, basically stating what we're doing. So by default, it just adds in this, but we're going to say creating code of conduct for repo. And then we'd leave a descriptive comment on why are we making this change, what does it fix, how to test this change. But in this case, it's just a file, so we're just do file added to protect us. If you know of a certain person that's going to want to review this, you can auto-assign, or you can assign a reviewer for this to speed up the process, or you can assign yourself. So I'm going to assign myself as an assignee on the pull request, and it'll do a diff between those and give you what has changed. So if it's green, it's an addition. If it's red, it's a removal. And in this case, we're adding a full file to this, so it's all going to be green. We create the pull request. It will check to see if it can merge without any conflict. If it comes back all green, you know you're good. We merge our pull request, confirm the merge. And as long as the merge was successful, as we see here, we can delete the branch. So in the case of branching within GitHub, or Git in general, branches are very short-lived, other than your trunk branch, your root branch.
When you did the pull, okay, where were you pulling it from? You had just added that object. Was it already in master, or was it a temporary workspace?
It was, so when we created the code of conduct,
Yes.
it asked, where do we want to commit this to?
And it went to a branch.
And we told it, go ahead and create a new branch. So it generated a new branch for us on the remote with a code of conduct feature branch name. When I created the pull request, in this case, it automatically opened up the pull request form. It did a comparison between that new feature branch and the branch that I told it to, whether that was dev or master. And so when you commit that, or when you send that pull request in, it's going to state this change is what is being requested against this branch. Do you approve it? And as an approver, you have the right to either accept it and allow it to be merged, or you can deny that pull request and give note of why you're.
But if the term pull is throwing me, from which direction?
Okay. Yeah, so the question was, so the term pull request, what does it exactly mean? So pull, it is confusing. So the pull request terminology is based off of, I have code I want you to pull into your dev or master branch. This is the request that it belongs to this pull that you're going to do. So push, like, I'm trying to think how to word this. There is a push. So you have a git push command, and that is working locally and moving it up to your remote system. The pull is when you're pulling code into a new branch structure on your remote system. And so push is a little bit more aggressive. I know that sounds kind of goofy to think of that, but push entails that you're forcing something in, whereas a pull, you have to accept it. And so
Okay, but when you accepted it, where did it go?
it went into the branch that we did the comparison against. So in this case, it went from the code of
Branch is pulling the other branch in.
You pull it into the main branch.
Yeah, you're pulling it into what is effectively your production system. If I'm understanding.
in this case, we're pulling it into our dev branch because I defined that was a comparison branch that we were making.
So it didn't go to master?
No, you can, and you can protect that branch.
But in this scenario, you sent it to dev.
Correct.
You pulled it to dev.
Correct. Pulled it to dev. Yeah, I know. It's a little.
Is pulling it always upwards? Like, you know what I mean? You never pull the other direction, would you?
So the question is,
Sort of going back towards the main branch.
yeah. So the question was, do you always pull upward into your branch structure? Can you do it both ways? I guess. Yes, you can go from master to dev. There may be reasons to do so, but I wouldn't suggest that. If that was the case, it's probably because you didn't have branch protections in place, and so you allowed a commit or a merge to go against your master branch, and you needed to clean it up.
Concept, and for me, because it's been a TFS type concept for me, that the fact that you just made a statement that you want to bring something out of master down to dev. You want to refresh something.
Yeah.
Something busted okay, badly. That's not a pull?
It would be. It would be a pull request from master to dev.
Okay.
And that could be a reason. You could have had a development team of 10 people. They've thrown in a bunch of code into your dev branch, and they've messed it up. You can't roll back any of those. The best way to do it is just take what currently works in production and move it into dev, and that would fix your dev environment, get it back into a clean state. So that would be a good example of that.
So the pull would overwrite the changes that are made in the existing branch.
So, say again? Sorry.
So if I have a dev branch and I made a bunch of changes in that dev branch,
Mhm.
and then you pull from production, then it overwrites those changes or it merges with those changes?
So the question would be around, I guess, permissions. Who would be the one that would merge from master into dev? In the case that would overwrite existing development work. So you can do selective merges. So you would definitely not allow anybody and everybody within your organization to do that merge. And that goes back to communication anyways. So you would definitely not go from master into dev unless there was just no way out of that option. Does that answer your question? Okay.
It sounds to me that you would create a second dev branch. That would be your example. But she was saying it would be overriding. Is it overriding, or you're creating a second dev branch from the main trunk? When you do a new pull, right? The dev has basically got corrupted, right? You made
Correct.
changes or whatever. So to go back, you go back to production, or at some point.
Yeah, you would go to your trunk. Yep.
Pull a new branch.
You could, yes. You could create a brand new dev branch, notify that the new dev branch is enabled, and delete the old dev branch, or lock it down to be read-only. That way you keep the history of it. If you needed to pull something out, you could merge it if you needed to. So yeah, that would probably be the option.
So we have a question from chat about confusion between the dev and add code of conduct branches, and what is the difference between the two?
So the dev branch, so branching is whatever you need it to be. Branching is a way of creating a bucket to store changes of work. So so my coding standards are I always have 2 branches at all times in my remote system. I have my trunk-based branch, which could be master, could be whatever you want to call it. And then I always have a development branch. From there, I may have feature branches based off of work that I want to introduce into the stream. In this case, when we created that code of conduct, we had 2 options. We could commit it directly to an existing branch, or we could create a new branch with this change only. Just to go over what a pull request was, we created this feature branch in our remote. Normally, I would not push up a feature branch into my remote system. I would keep it locally, and I would merge with my dev local branch, and push my dev up to my remote. I don't want the remote system to get muddied up with a ton of feature branches. It just makes merging a lot more difficult for me. So, does that answer the chat question?
I think so.
Okay.
And if I could take a quick stab at pushing and pulling,
Okay. Yeah.
just in case there's still any problems. Remember that Git's a distributed system, meaning that there is no central repository. And I think a lot of people have in mind that there's the central repository that everybody's committing to, and that is the source of truth. With Git, yes, GitHub makes it feel like there's a central repository, but even then, it's not really. It's still distributed, meaning that Josh wants to push a commit to a repository. He creates a pull request asking that I pull his changes in to my repository. I can choose whether or not I want to do that. He doesn't have final authority on this because I own the project. And vice versa, if I decide that I want to commit to one of his projects, I'm going to pull everything he's got. So pulling is bringing in. I'm going to make whatever changes, commit them, then I want to push them to him. But I don't have the authority to force that on him. All I can do is say, here's a bundle of changes. I would like you to pull that in. So I would like you to bring those changes into your repository that I don't have access to force them in. So that's how push and pull requests all make sense in the end, but terminology can be a little weird if you don't think of it as a distributed system. If you're trying to think of it as a central system, it can be hard to think through.
And the benefits of a distributed system are that it can be recreated. So if your remote ever goes out into the weeds, you could recreate your repository from an existing copy. So me being the project owner, most likely I have a good copy of that on my system. So if GitHub was to go down, I could spin up a Git server with that code and we could continue on. We wouldn't lose all of our code. We may lose a couple changes, but we're not going to lose everything. So I think this will become a little bit more clear as we get into the demo of working with code. So we'll get through this. Basically, I'm going to delete the branch to clean it up. We go back to our repo. We see that we had a pull request into our dev. We have not moved that request into our master. So if I go to my dev branch, I see I have a code of conduct sitting here, and I didn't have that in my master. So we need to create a new pull request to pull those changes from dev to master, because I want my code of conduct across my full environment. So we'll do another pull request. Nope, the other way around.
So while you're doing that pull request, I got another question. How would you use Git with SQL Server?
There's a couple tools out there for source controlling your database code. You have SQL database projects within Visual Studio where you import the schema into a database project, which then can be source controlled. You have third-party tools like Redgate SQL Source Control that is now also leveraged with SQL Change Automation. To source controller stuff, Idera has a version. So there's different tools that you may use. Your teams may already be using it internally, and you just may not be aware of it if you're not a developer within a certain group. I personally, within my organization, we use SQL Source Control through Redgate, and it works very well. It works with both Git-based repos and VS, the TFS model. So we'll create our pull request from dev to master. It'll check to see if it can merge. We'll merge the pull request, and now our branches are intact, or identical, sorry.
So in theory, the merge was a push,
So we'll set this up real quick, but when we were talking about security, one of the things that we touched on was branch protections. So branch protections ensure that people can't merge code in without approvals. We'll create a very basic branch protection. If you need to read more into it, if you go into settings on the repo, go to branches, under the branch protection rules section, you'll see a learn more and it'll explain all the different rules behind it. We'll create a very basic rule, and all it is saying for the master branch, we're going to require pull request reviews before merging, and we're going to require just one approval. But we can go up to 6 layers of approval if we need to. I don't know of a system that would require that many approvals, but I'm sure somebody will prove me wrong and find a reason. Maybe, yeah. Oh no. Go get my password. So there are certain things that when you modify against your organization or your repo, like something that's going to have some major effects on it, it will make you redo your password or replace your password back in. Deleting an organization, deleting a repo, you will have to put in your password again to ensure that you didn't walk away from your desk and leave your laptop unlocked. So if you created that branch protection correctly, it will tell you applies to one branch, applies to one file, applies to one folder. So you can create protections on set files. So that file that stores all your sensitive info, you may want to add additional approvals onto that one file. So if it was to get merged, you want that 6 layers approval if necessary. So all we're going to do is protect the master branch for now. And then we're gonna work some changes. So when a feature is requested, a bug is requested, it all starts from an issue. You can generate an issue by just going to issues and hit new issues. And the very basic default issue template is pretty bare bones. You can generate templates through Markdown, and they get stored in a certain file structure. And so you could have a feature template, a bug template, a new blog post template, whatever you want to do. Again, GitHub is a file storage system. So I use GitHub to maintain my website, my blog website. I also use it to maintain my SQL user group. So if you want to come speak at our group, you open up a new speaker issue, which then gets tied to all these other workflows. So you can use it for about anything that you want. So we'll create a test issue to track some work. We can assign it to somebody. In this case, I'm going to assign it to myself. Labels are a way of organizing work. So the majority that you're going to work with are going to be enhancements or bugs, but you can create your own labels. So whatever you want. I have labels for my website that are for the different types of blog types. That way in project management planning, I can look across colors and see what they are. Projects is a Kanban-based system. Like if you go into Azure DevOps or TFS currently, it's your backlog boards that you see within that. And milestones are like epics within TFS. If you have a massive amount of work that needs to be done by a set point, you may roll it all under a milestone. So we'll create our first issue. And any changes against that issue will be logged here. Any communication, any new change sets that are being pushed to it, whatever happens will go here. And you can set up notifications within the repo. That way you're notified when anything happens. And you can set up addresses or a distribution group. That way it changes if people come in or come out. So guidelines on working with code within your organization will differ between what you want to do. Some companies may not make you fork code into your private account or your personal account. They may allow you to clone from the organizational repo and work from that and just create pull requests from, push your change up into a feature branch and create a pull request. The majority that I've seen, they require you to fork the organizational repo into your personal account and work from there. So to create a fork, in the top right section of the repo website, you'll just hit this fork button, and it will tell you or it'll ask you where do you want this to be forked at. And all forking does is takes a copy of the code of the repo in the organization that it sits in, and just makes a copy into your account. But it creates a relationship between the two. That way, when you when you make a change and you push that up to your personal account's remote repo, you can create a pull request between the two. So,
And in this scenario, again, is it a full file copy or is it a pointer?
it is creating a copy of the code into your personal account. And so there is a pointer, there's a relationship that's formed. So when I click on my account, you'll see that it's forking from this org, this repo, and then when it completes, we see it automatically goes over to my personal account. So I see that I'm now sitting in the J. Higgin account under the TriPass demo repo. It's forked from TriPass demo org/TriPass demo repo. Now, if I'm blocked from an organization, the fork is immediately deleted from my account. But any local copies that I have are not removed. GitHub does not have the rights to go down into your local system and delete anything you have. So bear in mind that when you're talking about, don't let a worker come in and work on their personal laptop from your systems. Certain measures need to be in place. So now that we have this cloned over to our system, I can make changes in an isolated environment without worrying about affecting the organizational copy of that repo.
So how is a fork different from a branch then?
Branch.
A fork is like a duplicate of the code, right? And a branch would be sort of the same thing, isn't it?
So the question was, what is the difference between a fork and a branch? So they're kind of the same. In theory, you're branching the code, but you're making a copy of the repo as it currently sits, and you're moving it into your personal account. So you're isolating the work. It's just you can't branch from the organization over to a personal account. Forking is a method of basically branching the code between that container of code to this code. It's the same base theory. You're making a direct copy of the code. It's just a different terminology for what it is.
So the product of a fork is not publicly visible where the product of a branch is? Or the outcome of it?
The outcomes are similar because you're making a direct copy of it. They're both visible. So like if I go back to our TriPass demo org, I can see how many times this repository was forked. As an owner of this repository, let me see, I have to remember where it's at. I think it's under, if I go into Insights, Insights and then Forks, I can see who has all forked this repo. Branching, you can't see that at this kind of layer. Branching is more of a temporary workspace, whereas forking it, you could have a copy, he could have a copy, he could have a copy. It's a way of isolating work in your personal account and only introducing a change into the organization when you are ready as a developer. And then the organization will merge that when they're ready and they approve those changes.
Yeah, it's also a good way to split out a product that you intend to break off. Like MySQL split off into MariaDB. They forked the project. They took a copy of the code as of a certain point, and now they're just going in different directions without intention of coming back together.
So now that we have the TriPass demo repo forked over to my personal account, I need to work with it locally. So to do that, we introduce a concept called cloning. So cloning, again, is taking a snapshot from the remote and pulling that down into my local system. So you can get the info behind cloning from this clone or download section of the repo. If you hit the down arrow on it, you have a couple options. You can open it up in Visual Studio. So most developers work from Visual Studio still. There's other tools out there, Visual Studio Code. What is the company? JetBrains has an IDE that works with it as well. There's a ton of them out there these days. Or you can just download the zip, which doesn't retain a a relationship to it. So when you download that zip, it's just taking a copy of it, putting it into a zip file, and there's no binding there. If you hit this clipboard, it'll copy it into your clipboard so you can paste it in. We'll then issue a git clone command. The first argument is the location of the remote repository. So that is that link that we just copied over. You can either change your directory to the directory you want it cloned in, or the second argument can be where you want it cloned. So we'll clone it. I must have already ran this. Sorry, guys. Always delete your test runs. So if your clone is successful, it will give you a status in the terminal. And so basically this is saying cloning into this directory. It'll tell you how many objects it pulled down. And then if it completes, it'll just say done. If not, it'll throw up a big warning on why it failed. And it could be that in the first case, it was that the directory already existed. It could be a permissions issue. You're trying to clone it into a file structure that you don't have access to.
And it gave you access to that because it's public?
Correct. That's on my personal account. So I was able to clone that.
So you have access, but if you've made it private, let's say this was an organization, we don't want the world seeing the code.
Mm-hmm. You would never be able to clone it in the first place because you'd never be able to get to it. If you've created a repository and you set it to private, and I, as a guy off the streets, take that link to that repository and try to go to it, it'll throw an error. Now, if you have read access to a repository, by default you can clone it.
And what I'm wondering is how did you log in? You log in from your personal PC to that in order to have that access, or?
Correct. So when you download, we kind of skipped that, which I apologize. So when you first install Git, you have to set some configuration settings. One being, what is your name? What is your email address? And when you initially connect into GitHub from your Git system, it will open up an authentication pane for you to authenticate into GitHub to pass that config setting into GitHub. And so if I go and change that password on my GitHub account and try to do a clone or push new code, I'm going to have to re-authenticate, reestablish that connection.
Yeah, okay, so that was what I was wondering, because I know that you're thinking, in theory, you would be doing this from a different PC from the actual person who owns it, and you would be a worker, and you would have had to already configure your Git to look at that, be able to look at that repository and have a password to get, and username to get in.
Correct. Yeah, you already have to have permissions to that system to be able to access it.
The difference between a fork and a clone. When you did the fork and you got a copy of the code down there into your local spot, there were still pointers back to the master, right? In a fork.
So when we forked the code,
When you clicked fork,
correct,
okay, it brought a copy down.
to my personal remote system.
Yes, that's exactly
Yeah.
correct.
Personal remote is what he said, Mark.
Personal remote.
It's
Okay.
not local.
No, I
Yeah.
understand. But clone gets you local.
Correct.
Got it, okay.
And then we have to, in a couple lines down from here, we're going to create a relationship back up to the organizational level repository. So we're going to form back a relationship. And this will come in play a little bit later on. So we'll navigate to our directory that was created. To create new branches locally, you issue a git checkout -b. -b means for branch. And we're creating it, and we're going to define it as the dev branch. So this is a local dev branch. This isn't the dev branch that we created up top. To see what our current branches are in our systems, you run a git branch, and the branch that you're currently connected to will have an asterisk beside it, and it'll be in a certain color. I can't say for certain that it'll be green because you may have some terminal color coding system that you've built out that color may be different, but it's going to look a little bit different than what your other branches are. So that just tells you what branch that you're currently in. We're going to assign an upstream to our current branch that we're connected to. So this creates that relationship now with my local system with the original copy of this code in the Tri-City Demo organization. So to kind of go over how to work with remote systems. So me being a sole developer, I'm probably not going to worry too much about this because I'm the only one introducing changes. But in the real world, you're going to be working with a team of developers that are going to be committing code and merging code all day long while you're working away at your task. So before you do any changes, especially if it's been a while since you've made any, you may want to pull down the latest version of that code. So what we can do is go back to our dev branch of the organizational copy of this repo, the original version. We go to the dev branch and we'll create a new file. And this is just to give an example of a developer that isn't me introducing a change up into the system while I'm working away. So we'll create the new file. It's now in our dev branch, but it's not in our master. We go to our file structure locally and we see that it's not present. So to eliminate the risk of merge conflicts, before I start working for the day, I may do a pull from the upstream dev branch, which will then pull any changes that have occurred against that dev branch over time. So now it's pulled that test file into my local dev branch. That way I can continue working on without worrying about having a merge upstream that has an issue. This kind of goes back into feature branches though. So I keep a dev branch locally. That way I can test my merges before I go upstream with stuff. So from my dev branch, before I start working on anything, I create my feature branches, and that's where I work from. And then I'll go back to my dev branch. When I'm done with my feature branch, I'll go back to my dev branch, do a pull from upstream to get everything back in sync, and then I'll merge my feature branch locally into my dev branch locally to make sure it will work. So by the time it gets up to the remote for us to do the merge, it's as easy as it can be. And the next test will go over that. So now that we've got our test file back in here, we'll create our first feature branch. So we'll issue the git checkout-b command again, create the feature try-pass demo branch, and we see within our branches that now that is our selected branch. Everything matches up still. So we'll create a test file, or a sample file that is our change for this. So we see our sample2 file is now within our directory. If we do a git status, this checks the current status of the branch that you're sitting in. So we see down here that on branch feature try-pass demo, we have an untracked file because we've created a brand new file to the system. By default, Git does not automatically start tracking changes. We have to tell it to start tracking this file, or tracking new files, sorry, not tracking changes. So you have to issue a git add command. And if there's ever a time that you don't know for sure what the command is, get out of Zoom it, you can run let's see, if you issue a git help and then the command, it will open up a web page with details on that command for you to go look at examples, what are the arguments that are needed to do a certain thing. So to track the change, we'll do a git add and give it the file name. If we go back and run our git status, we'll see now that on branch feature try-pass demo, we have a new file, and it's the sample2.txt file that we're expecting. We then need to commit a change. And so committing is a way of staging these changes. It creates a snapshot for us to do something with it later on, whether that's we're going to push it up to our remote, we may need to commit a change or stash a change because a new issue has come in that we need to work on. In this case, we'll just go ahead and commit it.
Those arguments, the A and the M, does it just commit whatever's?
So the -A is all. So you can be selective in what you want to commit from your stage, and then the -M is the message that you want. So what you'll pass into the commit, you want it semi-descriptive. You don't want to write a book, but you want people to understand what this commit was for. And so we can see that by going to git log. And so what this will do is it'll give you a history on this branch of the changes that were committed. I usually will run this first thing in the morning because I forget and I want to know what I did the night before. So I see that this commit was made against the feature try-pass demo branch. Josh Higginbotham, my email address, made this on this date at this time, and he added the sample2 file. And if you hit enter, it will just continue down that history of changes that were made against that current branch. So we'll get out. So to kind of show you how the branching works behind the scenes, we see that we have our sample2 file that we created in our feature branch. If I do a git diff, which is basically doing a comparison locally between the current branch that I'm sitting and the branch that I defined, I see that the diff comes back with a new file was added to the feature branch that I currently sit on in comparison to the dev. If I go back to my dev branch, go back to my folder structure, I see that sample file is no longer there. So by committing that change, I've staged it. So I can jump back to other branches if I needed to do additional work because of that. To merge, and again, this is all personal preference. So before I will push code, I always merge it into my dev branch to ensure that it will merge accurately or without any issue. So again, say it's been a couple days, I'll go pull the upstream, make sure it's up to date, and then I'll merge the changes from the feature branch into my local dev branch. So I see that the sample2.txt file has been added to my dev branch. And if I go to our folder structure, I see the sample2 file is now in the folder structure.
And the arguments to that merge,
So
what are you handing to it as the argument?
So the question was, what is the argument that we're passing into the git merge? That is the branch name. So when we issued the git checkout command to dev, we moved out of the feature branch into the dev branch. The merge command is from my current branch, what is my comparison being ran against? What am I merging from?
So you're merging from the feature try-pass demo into dev.
Correct. And we're taking the changes that are from the feature branch and we're pulling those into our dev branch locally. So anything that's committed, I need to get that back up into a remote system so I can merge this over to our try-pass organizational repo. So to do that, we're going to push to the origin. And in this case, the origin to our local repo is my personal account's copy of this. And so I'm defining that I want to push to the origin, the dev branch. That could be anything. We could push up the feature branch if we wanted and deal with our merges up top, but in this case, we've dealt with our merges down below and we should be fine. So we'll push our changes up to our dev branch. We see that we didn't have any issues pushing these changes over.
If you had a conflict, would the merge fail?
Correct. And you'd have to deal with the merge locally at that point. And those things will happen. So this goes back to the importance of ensuring that your branches are short-lived. You're not holding on to changes for too long. This goes back into talking with your other developers, ensuring that you're not modifying the same things at the same time. But there's gonna come a day that you're gonna have to resolve a merge conflict. If you're not really strong within the command line interface, I would suggest a tool to do your merges. When you download Git, or when you create a GitHub account, you can download Git Desktop. That's their proprietary tool for working with source code, and it has a merge tool in it. If you struggle with command lines, I would go with a GUI of some sort. You can do about 90% of what you need to do through one of those GUIs. The other 10% you can Google and you can figure out. I just show you the command line, because if you can get the command line down, then you're golden. So let's see if I go back to we'll go back to my personal account. Where are you? So we've pushed up our changes. So we see our test file is present from the change that we made in our TryPass demo org, and we see the sample2.txt file that we created. We need to get this code over from our personal account now into the organization. So to do so, we have to issue a pull request. So when you're doing a pull request with a forked copy, again, this relationship was formed when we forked it. So it's going to create the pull request with the base repository as the original owner of this. So we create our TryPass demo, or our pull request, off of the TryPass demo repo, the dev branch, and the head, which is what is the branch that we're sitting here. It's a JHiggin version of that repo, and the dev branch. So we'll say introducing new sample file. Give it a nice descriptive message. This would obviously be, what are the changes that were made? Did we test it against X amount of systems? This is how you need to test it. These are, the stakeholders that need to do the UAT on it, so whatever your organization defines. And then we look that we've created this new sample2 file. We'll create the pull request. It'll check to see if it's mergeable. We'll confirm the merge, which will then bring the code over into our original organization. We'll go back to the original organization to verify things. So we'll go to the dev branch, and we see that the test file is there and the sample2.txt file is in our dev branch of the original organization. So now we're ready to move this into our master branch. We want to do a release. So we'll issue a new pull request. We'll say merge dev to master. We'll go and verify the changes. So we created a test file with test file in it, sample2, nothing bad. We'll see in the reviewers that at least one approving review is required. We went through the exercise before that we created a branch protection rule on our master branch. So this is basically stating to the requester of this pull that, hey, just so you know, when you issue this pull request, it will have to get approved before this will get introduced. It's basically all this is telling you. So we'll create the pull request. It's thinking. And we get a nice big red X, basically saying there's something up with this merge. In this case, it's nothing bad. It's just saying that a review is required, at least one approving review is required by reviewers. It gives you a nice learn now or learn more section so you can learn why you got stopped and that it's being blocked. As an administrator, I have the ability to overwrite this rule. There is a setting within those branch protections that say even administrators are blocked from being able to do this. So again, you may have one account that has full blush rights. That's your service account that nobody has the password just by nature. They would have to go get it. But even as an administrator, you shouldn't be able to bypass policy. You should still go through the formalized process. In this case, we will violate policy. But you have to admit that you're going to do it. So I'm going to say, yeah, I want to use my administrator privileges to merge this pull request in. So we'll confirm it. Yes?
Out of curiosity, so if say you, as you have to check that the administrator went and overrode the review process and whatnot, does that mean anybody who's a reviewer would get notified of this, or what would happen?
So by default, no. You would have to set those notifications up. So there's different tools. So sorry, I should have repeated it. So the question was, if an administrator overwrites a policy, will people be notified of that? By default, you would have to be added to those notifications. So there's certain areas that you have to set them up. That could be all personal preference. You could get them by email. I have them set up to my Slack channel, so when new issues are generated, pull requests are generated, I get a notification in my Slack channel. You can even feed it to Twitter. Whatever tool you want, GitHub is pretty open to whatever tool you want to use. That's one of the nice features. If you go, we'll touch on that in a second. I'll just open it up so we can come back to it. We'll finish this up and I'll show you some kind of cool stuff. So we've issued our pull request, and now all of our changes are in our master branch. Forgive me, I did miss something, and that was associating that fix to the test. So our issue didn't get resolved. I just realized that to basically to tie a commit or a pull request to an issue, all you have to do is in your message do # fixes 3, whatever the issue is, so the issue number, and then behind that is the message, and it'll associate that change to that issue. So it's kind of like in Visual Studio currently, if you associate a work item, or if you link a work item to a change in Visual Studio, you can either choose to associate it or resolve it. Those are your 2 options. In Git, you have a ton of different options. You can do fixes, closes. If you go to the Git book, there's a list of the different keywords that you can use. Apologize for not catching that until now. We could say fixes with latest merge to master, and we could go back and get that merge number. So we can go to pull requests. We can go to our close pull request. And we can, this is for when you screw up. It's going to happen. I do it a lot. But we can just put some annotation in the issue that this was fixed under this merge and put the link into that item. Normally you wouldn't do that. You would associate it. So as far as add-ins to the Git process to make your life easier. So GitHub has a marketplace just like Visual Studio has. If you go into TFS, you can see it. These are all the add-ins. The majority of the stuff you find in the marketplace are free for open source projects. That's one of the conditions I think that they probably enforce as a business model for open source projects. And that it could be based off of, if it's a monitoring tool, it could be based off the amount of, the requests that get hit to it, something along those lines. But if you go in, you can see all the different add-ins that you can do. We'll look at this one. See, open source, $0. So, you know, definitely get your foundation set within your structure, making sure that your organization and your repositories are secure, but then go look into the marketplace and see what you can add in to make things a little bit easier. As far as notifications, you can be notified by email. Me personally, I don't like being flooded by white noise within my email. So I'll send them to a Slack channel. So in this case, I have notifications set up when issues are created in our Louisville SQL Server user group repo. And it'll give me an output of that issue. That way I can see what the issue is, and I can decide whether I want to go take a look at it or not, just bypass it. It has integrations into Microsoft Teams, so if you use Microsoft Teams at your workplace, you can have that fed into a channel there instead. So it's pretty open. All right. So the last thing I want to show you is just kind of what you can do with GitHub, and then I'll open it up to questions. This is one of the cool things that we've been working around. We still haven't implemented it across our systems, but we have so we maintain our Louisville SQL Server user group through this is the intent of it. So we have a speakers repo. And so basically, if you want to come speak at our group, or you want to request a certain subject for us to go hunt down a speaker to bring into our group, you can come here, open up a new issue, and I've built out these templates, a new speaker submission or a request a session from the UG. And to show you how those templates work, we'll open up this new speaker one, and I've defined out that I want you to give me what your topic is, what's the description, what's your bio, all the things that I need to be able to schedule out this session. And then once the issues are created, we can link them to the speaker submissions project, and we can manage them and see what current state it is. That way, if I'm working on a speaker submission and I've brought it to the scheduled section, Jeff, my co-organizer, doesn't have to worry about it being done or not. So it's just a way of working with projects, is all this is. So I'll bring it back into the resources section. Let's see. Just for you to take a picture of that if you want. Again, all the material will be sent off to Kevin, and he can send it to you.